Hi, welcome to my channel with Thames class with Ms. Vishaka. In today's video, I'm going to discuss about organic synthesis by using the Grignard reagent. What's a Grignard reagent and how it is used to do certain organic synthesis. So that's what we're going to do with some examination question as well to get a better understanding. The honor goes to the Victor Grignard. He is the person who has been given this synthetic pathway to the world, and he was kind of honored by giving the Nobel Prize for this attempt because it is Grignard reagent is made up with organic and the metallic combination. Organic plus metallic, so we call it is organometallic synthesis. So that the organic part combined with the metal, and it is the this when it work with this the magnesium with the bromine attached to carbon atom. So this is the basic part of this organic synthesis based on the Grignard reagent. The organic compounds can be synthesized by using Grignard reagents are basically primary, secondary and the tertiary alcohols in the carboxylic acids. So in case if it is needed kind of an alkene to be synthesized, so should obtain the alcohol first and then remove water molecule by dehydrating agent, then we can obtain the corresponding alkene. Also, if it is in a mine can be produced, so amide is needed, can be obtained the carboxylic acid and then converting to the corresponding amide or whatever the any other acid. Chloride can be prepared, or also it could be amide can be synthesized. So these are the other ways it can be produced. So best thing and the most primarily we can obtain the alcohols and carboxylic acids by using Grignard reagent. The main part of the Grignard reagent, which is the RMgPr, can be varied, but once it is being heated under a flux with dry ether, we use dry ether because Grignard reagents reacts with water, so it is not using any aqueous solution when handling with the Grignard reagent. So always it is the solvent as dry ether. The main thing in this synthesizing procedure is to obtain alkyl magnesium halide, but it's often the bromide because there's a special stability when it is producing magnesium bromide directly bonded to the carbon atom. So this is the basic part in concerning the Grignard reagent. Once this has been producing, it can be used in for three different ways. We can use as methanol, ethanol, as well as it is a ketone or as the carbon dioxide. It could be used for different reagents. Either it can be used as methanol, so we can get the primary alcohol, or it can be added to ethanol, so can obtain the secondary alcohol. We can add into a ketone, then the product will be a tertiary alcohol, or as it can be added into carbon dioxide, then the product would be the carboxylic acid. This schematic representation shows once we obtain the Grignard reagent, if it is treated with methanol, our product would be a primary alcohol. Once you obtain the Grignard reagent treated with the second part, which is be treated with ethanol, it could be the secondary alcohol. Also with any ketone, we get the tertiary alcohol. When we treated, once we reach this Grignard reagent with carbon dioxide, this is the fourth step would be carboxylic acid. So basically we can produce primary alcohol, secondary alcohols, carboxylic acids as well as tertiary alcohols by using Grignard reagent. Even though we can obtain basically these four, after obtaining the alcohol we can obtain aldehyde or proceeding from that can be oxidized into carboxylic acid also. When it comes to the secondary alcohol, we can obtain further with the ketone with that on oxidation. Same as with the carboxylic acid obtained with the Grignard reagent treating with the carbon dioxide, it can be further changes into an amide or is the acid chloride. Once it is reached this the carboxylic acid, so it's a huge number of different compounds can be synthesized depending on what's the final product. We should design our Grignard reagent and then we should design what would be the next thing to be added. So the example number one I have taken, it is given you ethene to convert into a primary alcohol, which is propan 1-ol. So it's the immediate difference can be seen. There are two carbons at the beginning and it's an alkene. And this the product has three carbon. Obviously one carbon has to be added, which is the primary alcohol. We should use methanol as one of our reagent, but before that we should produce Grignard reagent by using this ethane. As ethene is unsaturated, we cannot use it further up. So we should first treat the ethane with the hydrogen bromide. So this addition of hydrogen bromide as an alkene react with the hydrogen bromide. So it would be reacting with that. So it is changing into the bromide on one carbon as well as CH3, CH2 on other carbon. So our primary concern is to produce this compound with this the bromoethane. So once we started the bromoethane, we should convert this into the Grignard reagent. To convert into Grignard reagent, we should add magnesium. It should be treated with heat under reflux. So when it is dry ether, heat under reflux, these are the two conditions. It is used as a dry ether as the solvent and it should subject to heat under reflux, so we can convert this compound into the Grignard reagent now where the magnesium get bonded to the bromine as well as the carbon. So our first step is to convert this into the Grignard reagent. So you can see it is with the 2 carbon, but our given product contain 3 carbon. Once it is given this one, at the same time as the primary alcohol the product is, we should design our next step according to this. So in the next step, we can see that through the carbon-oxygen double bond, it is being bonded to MgPr and this kind of intermediate compound is produced. Once we get this compound, we can do the acidic hydrolysis. In the next step, so once we get the intermediate, so it will be the water molecule is used up, so it is now oxygen, nitrogen, new bond is produced and this part gets separated as MgBrOH. So we could synthesize our compound which is 1, 2, 3 propan 1-ol which is started with from the alkene by using HBr the very first and this would be with 3 basic stages we could produce it through the Grignard reagent. We move on to example number 2. If we need to design the pathway to methyl propan 2-ol, which is a tertiary alcohol, so obviously it is the propan in the synth, they should be having 3 and it is the number 2 has the OH and it is the 2 methyl. So there should be methyl group. Once you start writing, you can identify it's a tertiary alcohol. To obtain the tertiary alcohol, obviously we need the compound is a ketone. So it's a ketone we need. Supposing if we need ketone, it is having only 3 carbon. So the additional carbon on the second carbon on the methyl group has to come from the halogen or alkane. So you should do some kind of analysis before starting this pathway. So get an idea about how many carbons are in the product and how many carbons should be involved in the beginning. At the same time, if it is a tertiary alcohol, in one of the stage a ketone has to be used up. We'll see how we can do this synthesis. So this preparation we should add 1 carbon because it is this we are having propanol which is having 3 carbon only, but the product should be having 4 carbon. So we get that the bromomethane. Bromomethane is allowed to react with magnesium in dry ether, heat under reflux, we get the Grignard reaction and it is allowed to react with propanol. So I put in the red color the carbon from propanol. So we get this intermediate. Once we get this intermediate, so it does the acidic hydrolysis. So it is the water molecule comes here, H and the OH. So it is obviously hydrogen is attached to the oxygen over here. So there would be the alcohol, which is the tertiary alcohol is produced. So it is this the OH attached carbon is attached to three carbons. So it's a tertiary alcohol. Tertiary alcohol, we need ketone at the same time. This is for the reference only. I had written that the water molecule comes non, so you can just mention the acidic hydrolysis. It's understood. MgP and the OH separate, so the compound would be the organic compound is that the 2-methyl, so it has to be that propan 2-ol, 2-methyl propan 2-ol, which is to be manufactured, which is to be synthesized starting from it's a Grignard reagent. The Grignard reagent we need one more carbon as propanol has three carbon already. We should get one carbon. So we should we should plan our original halogenoalkane accordingly. I have taken an example Edexcel IAL October 2023 paper, question number 20. This is WCH15 paper. This is the unit 5 WCH15 paper. Question number 20 part. It says devise a synthesis to convert bromobenzene. This is very much clear that you should understand what would be the product in the reactant. So the bromobenzene into benzamide include. So those things are very important. Reagents, conditions, and the structures of intermediates. So this question offers 7 marks. So these 7 marks to be total 7 marks to obtain. It should be very clear what the question is, and it should include in your answer the reagents, the conditions, the structures of intermediate plus synthesis to convert the final compound should be the benzamide. Original initial compound should be bromobenzene. Now we'll see how we can plan the synthesis route and how we can achieve the our final product which is asking in the question. By looking at the reactant, the product, you can see obviously the amide should be started with the carboxylic acid. So you should convert your bromobenzene first into the carboxylic acid, that is the benzene carboxylic acid, and then only you can do react it with ammonia. So it would be the next product would be an amide. We'll see step by step how we can achieve this synthesis. The first step it should be to obtain the Grignard reagent as it is asking the reagents as well as conditions at the same time the intermediate structures. So you should go with one by one steps like that. We have to first get the Grignard reagent. So the second step should be the carbon dioxide involved because we need to introduce the carboxylic group. So it is the carboxylic acid, carbon oxygen double bond and another bond being broken and joined with this benzene, and it is the OH group has been achieved, and later it is I added the second step being together and the hydrolysis. So when it is been subjected to acidic hydrolysis, so it we can obtain the carboxylic acid. So it should be the carbon dioxide followed by the acidic hydrolysis. We be obtained the COOH group to the benzene, which had been having the bromine at the very beginning. So this would be our next product at the end of this step 2. We'll see how we can proceed in the step 3 and the step 4. The two other steps should be once we get the carboxylic acid, we can put the reaction with is the phosphorus pentchloride at room temperature. We get the it is the acid chloride instead of COOH, now COCl. Now it can be allowed in our next step would be with ammonia. So this is the benzamide. It is in our fourth step. So there would be certain times it is specifying the number of steps, but in this synthesis it's not specified the number of steps, but within 4 steps we could achieve our final product which is the benzamide. I hope you understood about how this synthesis took place as well as some background information regarding the Grignard reagent. Hoping to meet up you soon with another video. Thank you so much for watching the video.